This is part 2 of the one-way or between subjects ANOVA. We're going to cover some basic abbreviations. We have large N, which is your total sample size, little n, K for number of groups, SS stands for sums of square, which is the same sums of squares that we've covered in past analyses. We'll go over how to do that again though. We have mean squared, degrees of freedom, grand mean, and group mean. These are all going to be used in order to help us calculate an ANOVA, a between subjects ANOVA specifically. Our example is going to be comparing how many words you can memorize based on a given strategy. We have rote memorization, which is where somebody just keeps saying it again and again. Imagery, where you associate an image with it, such as a ball or a bear. And then there's story, where you would put things together, as in how many words you can remember using a story, saying like, the ball was thrown by the bear and then was hit with a baseball bat by a cat. And that'll help you memorize those 4 words. We want to see which of these 3 strategies works the best. If you recall from the previous video, we are talking about how an alternative is at least one mean differs from the other. Not all of them, just one. Alright. We are going to be talking about how to do the standard sums of squares. We have over here, sigma is a score minus an average squared. And so this can be any score. It can sometimes be a mean. It can be a group mean. It can be anything. But this is the standard way about doing a sums of squared. It's going to be each individual score subtracted from the mean, then squared, and add all of those together. So if you do it 4 times, because you have 4 individual scores or 4 means, you subtract each of those from the mean that you're comparing it against. So the individual mean, maybe from a grand mean like we're going to do, an individual score from a group mean or a grand mean. And each time we do that, we're going to square it and then add those all together. And that'll give us our sums of squares. Here's how we're going to go and calculate the first sums of squared. As previously talked about, the sums of square total. That is how much each individual score differs from the mean. And if you can recall, our mean was 5.833 for the grand mean. And so what we do is we do 2 minus 5.833 squared. So let's take a look at that. That's 2 minus 5.833 squared, 14.69. And look at that. We end up with 14.69. We do it again. We have 4 minus 5.833. And we square it. 3.359. We round that up. It's going to end up being 3.36. We do that for all of them. Now notice here, when we go across, it stays the same. So 4 over here still will give you that same value over here. We go through and we do this for each and every one. When we add up the columns as such, and then we add those up, and that's going to give us our sums of squared. So the first column is going to be 50.88 plus 14.88 plus 61.56, which will give us 127.32. Alright, now we've gone from total, and we're going to do within. Remember, within group variance deals specifically with how much each score varies from that group mean. Because within group variance uses each group's mean, we're going to take the individual score and subtract it from the corresponding group mean to get us our sense of sums of squares. So if we look up here, we see the individual score minus its little g, so it stands for group mean. So we have x, which is 2, and we know from earlier that our group mean is 4. So we do 2 minus 4, which is negative 2. Negative 2 squared, 4. Now, unlike before, where we could take that and take that 4 for that 2, we can't use it in any other group. We can only use it in that particular group. 4 minus 4 is 0. 0 squared is 0. We do that for each of these scores, add them all up, end up with 24. The middle one we have 5.5 as our group mean. 4 minus 5.5 gives us negative 1.5. Negative 1.5 squared going to be 2.25. Go through and do these all the way down. Finally, we have story. 6 minus 8, because as we know from before, the group mean for number of words recalled for story was 8. 6 minus 8 is going to be negative 2. Negative 2 squared is 4. Positive 4. We add these all up. So we take the bottoms. This is 24. This is 14. This is 24. 24 plus 14 plus 24 gives us 62. You're now going to look at between group variance, sums of squares. Notice there's the little g right here. That little g stands for group mean. Large G stands for grand mean. So we know from before that the row rehearsal group mean is 4. The grand mean is 5.833. Now this little n stands for sample size, so how big that particular group size is. As we saw on the previous, we have 1, 2, 3, 4, 5, 6, 7, 8. So that's why we use 8 here. It's still the score minus the comparative mean squared, but for between, we multiply it times the sample size to give them more weight depending on the group. So we go through and we do this math. 4 minus 5.833 squared gives us negative 1.833 squared. Still have the times the 8. That becomes 3.336 times 8 gives us 26.88. Now we do this for the next two groups as well, because we have to do it for every group. Every score that pertains to it is how we do our sums of squares. We end up with 0.88, 37.57, add those all together and we take it. It ends up with 65.33. Now what we're going to do is we're going to take those scores that we had, and we should make sure we take note of them. And we're going to put them into what's called our ANOVA table. So we take our sums of squared between, sums of squared within, and our sums of squared total. We have our degrees of freedom between and within, degrees of freedom total. So we've already calculated our sums of squares. This might look complicated, but this is what we just did. We have our degrees of freedom. Remember, K stands for cool categories. So in our case, we have 3 categories. 3 minus 1 is going to be 2. Large N stands for how many people we have. We had 3 groups of 8. 3 times 8, 24. That's going to then be 24 minus our number of categories, which is 3. So it'll be 21. 24 minus 1 for our total will be 3. Now what we do is, notice it's sums of squared between over degrees of freedom between. So we're going to take this and divide it by that, and that'll give us our mean squared. For both within and between. Here we go. These numbers should look familiar from before. 62 divided by 21, 2.95. 65.33 divided by 2, 36.27. That'll give us our mean squared.